Welcome to Chapter 2 in SGD 113, Script Creation, Syntax, and Variables. This video is going to go through these notes right here, and with each new concept I introduce, I'll switch over to Unity and show the new concept in action. So without further ado, let's just go on. So let's talk about script creation first. Alright, so here's all the different topics we're going to be talking about in script creation. Of course, creating a script, naming them, how we can attach scripts to game objects in Unity. We're going to talk about the IDE monodevelop. We're going to talk about the Unity console and the important Unity function Debug.Log. We'll hit each one of those up individually. So when you're creating a script in Unity, there's a few ways to do it. I'll go ahead and show you guys the way I prefer to do it. So let's minimize this and go into Unity. Right here is a brand new scene in Unity. I'm going to create a new folder and call this scripts, and we'll just double click in that folder, and now we have a blank empty folder that we're going to store all our scripts in. I just like to right click in this empty window right here in our project window, go to create, and make sure you select C# script. That's the language we're going to be coding in throughout these videos and throughout this course. So let's create a new C# script, and let's call this player stats. Alright, when naming a script, there's a few different naming conventions we have to keep in mind here. Don't use spaces. Don't use any of these random characters. We can use underscores if we absolutely need to have a space within our scene or within our script name, and do not start your script with a number. Unity just don't like that. Alright, so with my script created in player stats, we have a few things here. If I select it in my inspector, I see an empty script right here, and notice how we have public class player stats. It corresponds to the name of the script you just created. This is the class name, which corresponds to the script's name. When renaming a script, make sure that you also rename the class name right here. I'll show an example of how that can mess up when we get into monodevelop real quick. Alright, so after we've created our script, before the script can even be executed in our game scene, we need to attach it to a game object. And sometimes you'll have scripts that just house maybe just stats for a player, like player stats. Alright, so what we're going to do is we're going to create an empty game object, and let's just pretend like this is our player. So we'll name that empty game object player, and notice how in our inspector there's hardly anything within our little column right here, except for some basic transformation values. So we can make sure the script gets executed by Unity. We're just going to click on our script, and I just simply like to drag it and drop it. And now you'll know in our inspector you can see how we have our player stat script visible whenever we select our player. If I deselect player, I don't see this in the inspector anymore. And if I say I selected the main camera, we don't see our player stat script. But when I go back to my player, we see my player stat script right there. Alright, great. So now let's talk about monodevelop. I'll show you how the renaming of the script in monodevelop is pretty tricky if you don't pay attention. We've already talked about attaching the script to the game. Here are a few different ways you can do it. I just showed you method 3. Just click and drag and drop it on a game object in our hierarchy view. So what's monodevelop? It's an IDE, which is an integrated development environment, and basically it is like a notepad editor, except it has a bunch of cool features that just a basic word processor won't, such as it'll highlight syntax, it'll autocomplete things for you, it'll help you format and get your brackets matched up. It's a good compiler. It'll take your code and it'll just make it, compiled so the game engine can read it, and it'll help with catching errors with our debugger. Alright, so if we want to see what our code's doing and debugging stuff, we have our Unity console right here. Remember this little window right here? This console right here is going to help us throughout this video and throughout the rest of your programming experiences with Unity. It's good for seeing different things printed out, such as debug.log messages, or if you have an error in your code, it'll display it in this window right here. Alright, so let's open up MonoDevelop for the first time. The easiest way to get into MonoDevelop is just to double click your script. Notice how MonoDevelop is its own program. It opens up its own window, and for all intents and purposes, it's just another program like Unity is, or my Internet Explorer or Chrome right there is. It's its own little thing, but it works directly with Unity. So what we see right here are a few different things. Here we have first two, using Unity Engine, using system collections. This is basically just standard scripts. You will never really touch them in this class. It's basically telling Unity, hey, there's a bunch of different things we need to pull from that are in Unity by default, and these two lines point to those things. We have our public class on line 4. As you can see, our lines are numbered right here. Our public class is called player stats, just like how we named our script right here. Let's go ahead and show an example of how renaming our script can be a problem, and also it'll show an error in our console message. So let's say, for instance, I wanted to rename my script and call it player statistics instead. So if I double click on the script now, it'll bring back MonoDevelop. And notice how our class hasn't changed, but our script name has changed. If we press play, we'll notice something right here. The reference script on this behavior is missing. This is an error message saying that, okay, whatever is going on with my script, things are all messed up now. It will not execute your code until you go in here and you update the name of the class here. And a good easy way to do that is I like to double click on the name here, Control C to copy, and we can just go into MonoDevelop right here and Control V to paste. And that's just a way to make sure that our class name and our script name are lining up. Now if we press play again, we have no more errors. So that's important to note about naming classes. Alright, so let's write our first thing inside of Unity. And what I like to do is I like to get my formatting correct. And to do this, I'm going to make sure I get all my brackets lined up. I like to have my curly brackets within the same alignment right here. That just makes it a little bit easier for me to see what's going on. In the world of syntax, which we'll get to in a second, you got to be very organized, because the first thing you misspell or the first bracket that you misplace or delete or have in the wrong area, it will mess up your code. So let's look and see what a console window will show us if we just write random gibberish inside of our script right here. We'll hit Control S to save, or you can go to File and Save. And let's go back into Unity, and we'll notice in our console window, player statistics 912. It's an error. What is this 912? Unexpected symbol. Well, that's because in 9 we can see how our scripts 912 line up with the lines right here. It's basically saying we have this gibberish right here, and then whenever Unity picks up void start, this is the first thing the script looks at. Whenever you press play, anything within these brackets, Unity is going to start executing. Well, before we even get to this void start function, we have all this gibberish right here, and it's causing Unity just to freak out a little bit. So we'll delete it, and you'll notice that now in my console, the error's gone away. So that's a quick way to display how errors in the console window work together. So I'm going to introduce. See, Unity console gives back text, errors, warnings, logs. We've seen the warning when we changed the name of the script. We've seen the errors when I wrote gibberish in the script itself. But let's talk about debug.log right now. Debug.log is your way to print things to the console window. So you can see text that you may want to have, or if you want to write notes in the console window, such If an enemy gets hit by a bullet, you can have it say enemy hit by a bullet in your console. So let's see how we can use debug.log. Alright, in our void.start function, remember this is the first thing Unity does. As soon as you press play, everything inside these curly brackets is going to be executed. So let's just make use of debug.log. Alright, so we write debug.log, and you'll notice how the ID is bringing up all this auto-completion stuff. That's because this debug.log is a function inside of Unity that is already preloaded. Unity knows what's going on, and it just makes scripting a lot easier. And we'll hit parentheses, and let's say we want to write hello world. That is the most basic first line of code that every programmer learns how to code. So I'm going to do a parentheses, do a quotation mark, and just write hello world. I'll close it with another parentheses and use the semicolon to terminate this line, meaning I'm done with this line of code. You'll see a few things in the window here. First of all, you'll see debug is in blue. That means debug is a function inside of Unity, or it's a pre-made set of scripts that Unity already has, locked down. And the .log is saying, okay, I want to use the log function of debug. And that just means, okay, anything in these parentheses, we're going to print out to the console window. You'll notice how hello world is in orange. That means that this is just a bunch of characters, a bunch of words. Print this basically word for word. And we'll close our parentheses and use that semicolon. Let's hit Control S. All right, and let's go back into Unity. And look on our console right here. When I press play, you'll see that I have hello world written out to my console. So that's basically what debug.log does for us. It allows us to see printed out messages, anything we want to see, and we'll learn more about the ways we can work with debug.log within the video. So let's just keep going. Alright, so let's learn about syntax. I've already covered a few things like curly brackets and aligning those brackets and making sure that you have semicolons and whatnot. So let's just go over what syntax is, okay? First of all, syntax is rules of a language. There is actually syntax in English, meaning the first letter of every sentence is capitalized. The end of a sentence has a period or exclamation mark or question mark. And it's basically just visual-based symbols, text-based symbols. It's the rules of a language. White space in Unity basically means there's nothing there. And then we've talked about keywords. They're colored in IDEs. Things like functions or variables such as int, floats, class breaks, continues. All these things we'll cover in a second. And different symbols. Order of operations is very important in the programming world. You may have come across this in a few math classes in the past. They're very important in programming because in the programming world, Unity reads lines of code left to right. And whenever you're using different math equations for, maybe stats of a character or enemy AI or just anything you want to use math-based, it uses the order of operations. Basically, the order goes parentheses, do this, then this, exponents, multiplication, division, addition, and subtraction. We'll go over a few examples of that real quick. So, in debug.log, if I wanted to read this from left to right, then Unity's going to know to look in debug, and then the .log function within debug, and then it's going to go to the right. It's going to see everything in this parentheses, hello world, and order of operations is in kind of play here in that it reads left to right. We'll get into more of the math order of operations when I introduce variables in a second. Just know to keep please excuse my dear Aunt Sally, if you've ever heard that acronym before. Please excuse my dear Aunt Sally. That's just a little device I've used and remembered over the years. Alright, so we've seen a semicolon. It's used to terminate a statement. And if we go into Unity or MonoDevelop, you can see that I have my semicolon at the end of this hello world. That's basically telling Unity, okay, stop right here. I'm done with this line of code. Now do it. All right. Parentheses, we've seen these here before too. And if you'll notice, they define order of operations as well as used in different kinds of functions, such as hello world. Curly brackets, we've also seen those before. We have our curly brackets right here. Within these functions right here, I've used the term functions a few times. For right now, we'll get into just accept that a function is its own self-contained kind of machine that operates all the code within these curly brackets. But to make sure that the engine knows that all the code within this void start function, where it all is located, we need to have these little curly brackets right here to say, okay, open curly bracket says, okay, all the code after this is what we're going to do. And the closed curly bracket, facing in this direction, says, okay, we're done with this block of code. And notice how I formatted it to begin with, so they're right on top of each other. And we'll also have different curly brackets nested within inside of each other. So here we have our public class player statistics. See the same curly bracket? And all the way to the end of this class, we have a closed curly bracket. And in between these curly brackets, we have two functions, void start and void update, all both with their curly brackets. Straight brackets, we're going to look at those when we defined arrays, which is basically a list of data. We'll skip that for right now until we get into arrays in a few chapters. Double quotations, we've seen that so far. It's basically used to help us denote a string of text, such as hello world, just a string of characters that we've made this sentence with. Comments are pretty useful. They're described by double /. So let's say we were writing in our code and we wanted to say, okay, here's where I'm going to write hello world. I can do double / and I can write, this is debug .log code for an example. Anything within this line of code is going to be ignored by the game engine. Alright, so that means we can write notes to ourselves as we're coding, and we can see this as an effect because we have a really light gray font color on here. And the default scripts already has this. This is used for initialization, which means as soon as we press play, all this code is initialized or it is executed. Everything in void start. And here we have void update, saying this update is called once per frame. That's very important. You might have heard in the past that video games run at 60 frames per second. Well, that means that if a game is running at 60 frames per second, then any code within this void update function, it's going to run every frame. So 60 times a second. So every frame, 60 frames per second. Syntax errors are going to really mess you up sometimes. They break the rules of the language. The code will not compile. You cannot attach Unity scripts if the code's wrong. If the code just won't compile, then you just can't use it. So what does compile mean? Well, let's pause this real quick. Let's go ahead and make a syntax error real quick. Let's suppose I forgot to put my semicolon there. Alright? And let's unattach the script from player. We can do that by highlighting player. We go to our player statistics script, and I can go to remove component. Alright? Now our player has no script. We have these syntax errors right here. Let's see, line 12. Okay, on line 12, I have a curly bracket. So something before line 12 must be messed up. That's that semicolon I messed up on. So let's try to attach a script that won't compile onto player. Alright. Well, it seems like Unity, maybe with an update, it allows you to attach scripts even though they won't compile. But it won't matter because even if you press play on the game, all compiler errors must be fixed before you can even enter the play mode. So even though you may be able to attach scripts, which I previously, in previous versions you were not able to, you still won't be able to play the game. So let's get back into MonDevelop and let's put that semicolon back where it belongs. hit Control S to save. We'll notice that my error is gone and my hello world is back. All right. I can hit clear on the console window to get rid of everything. And just to double check to make sure my hello world is working, I'll hit that clear. I'll press play again, and all the code is working as it should be. So sometimes when you're coding, you'll have no syntax errors, but you'll have a logic error. Even though the code compiles and runs perfectly and is attachable, and you can press play on the console and everything looks great, it'll give you weird behavior. So maybe you have a logic error within your health. Say whenever you get hit by an enemy, a logic error would be you gain health rather than lose health. Just different kinds of things you'll need to look out for. So let's get into variables now. I'm sure you've heard the term variables before, but we're going to talk about them in context of programming now. So we're going to look at what variables are, different kinds of variable types, variable declaration, and different kinds of mathematical operators such as plus signs, subtraction signs, where we can manipulate different types of variables. All right. So what's a variable? Well, it's an object for the storage of data, meaning anytime I need to save, let's say, the value of a character's health, I need a variable there so the game can remember, well, how much health does the player have right now? Well, I'll store that in a variable. And there's a very strict naming convention here. It's denoted by lowercase, uppercase, uppercase. So every single word within your variable name, you're not going to use a space, okay? The first word in your variable will be lowercase, and then every other word after that will be in uppercase. And Unity will read that as, okay, we need to put a space between these two words. And I'll show you an example of that when we declare our first variable in a second. So let's look at different variable types. And I'm going to give us real practical examples of how these variable types can be used within a game. Okay? So we have the int, which is short for integer, which is a whole number. They can be negative, it can include the number 0, and of course all the positive numbers. That does not mean that we can use decimal points, so 1.1 is not an integer, only whole numbers. And here's an example of declaring an integer within our code right here. So let me go ahead and let's look at that in action. Okay. Alright, so when we declare variables, we have to go above our void start function, almost like the very first empty space within our class here. We want to make a variable, and we want to call it an int of type int, and now we have to give it a name. So let's make a variable called player health. Alright, and we're just going to hit a semicolon there, and we'll hit Control S. Now Unity knows that there is a designated area where we can set any kind of whole number to say the player has 100 health. Alright, so let's go ahead and put the word public in front of it. A public variable basically means that any other class, any other script in the game can look at this code right here, or this variable, and it can access that variable. And it also does something else that's pretty cool. So anytime we put a public int there, let's select my player right here, and now we have under my player statistics, I have a player health empty value right here, and then I can assign any kind of value I want right there. So if I press play, give it 100, and press play, now I've basically said the player has 100 health. Alright, well, what happens if I don't want to have to type in 100 every time I run the game, and I just wanted to automatically the player start with 100 health? Well, that just means I'm going to have to assign this variable a value. And there's two ways you can do this that we're going to learn starting off. Alright, I can declare my variable. Remember, declaration is this line right here. I can also add a equal sign and make it say 100. Alright, so that's declaration and assignment in one line. We hit Control S and go back in here. We'll notice that the player has 100 health. I can even set this value to 0. And look what happens to this value when I press play. Alright. It stays at 0. So, when you assign a variable its value outside of the start function, then you can edit that value inside of the inspector. But what happens, what if I want to make sure the player starts at 100 health no matter what I type in my inspector right here? Well, we'll just delete all that we did right here, and we'll just say player health. Notice how the MonoDevelop is letting me autocomplete. I just hit tab there and it'll spell out the rest of it for me. Equals 100. Alright, I'll hit Control S to save this. And since everything in this little function, void start function right here, since everything is ran as soon as we press play, then no matter what I type in my inspector here, I can write 50 health. But as soon as I press play, it's going to assign it that 100 value. Remember, anytime you press play, everything inside of void start is executed. So even though I type 50, player health now equals 100. So that's two ways we can assign values to our variables. Alright, so let's learn about some other types of variables, okay? Let's look at the float. Alright, remember how integers didn't have decimal places? Well, that's where floats come into play. Fractional, decimal numbers, 1.0, 0.1, 0.01, all the different kinds of decimal numbers you can think of. Here's an example of declaration and assignment. There is one small difference between assigning a value to a float versus an integer. You'll notice I have this little f right here. Alright, so let's make a public float and call this player shields. Alright, I'll hit Control S. We'll go into Unity. If I select my player object right here, I can see now I have player shields right here. Alright, so player health is going to be in whole numbers. Player shields will be able to have decimal points. Alright, so within our void start thing, function right here, let's do player shields and set this to 99.9f semicolon and hit save. Alright, so now when we press play, we're going to have 100 health and 99.9 player shields. What happens if I get rid of that F? Well, let's hit unhit play. Let's delete that F. Let's save the script. Control S or save. And let's press play. Well, we get a compiler error. Let's go to our console and says what's going on. Literal of type double cannot implicitly convert it to float. You got to add the suffix of F to create a literal of this type. So whenever we don't add F's here, Unity gets confused. There's a different type of concept called doubles within the engine. We're not really going to go over those, but floats are by far more useful to where we are right now in our study of programming. So we're just going to have to make sure we put that little F there. We'll hit save, and now when we hit play, everything works like it should. Let's go over another variable type called the Boolean. A Boolean value is a simple true or false, yes or no, 0 or 1. It can only be one thing or the other. Alright, so let's see what we can do inside of Unity with Booleans. We can have a public bool, B-O-O-L. I misspelled public there. Notice how it didn't highlight in that teal color when I misspelled it, but now we're good. And I can write is alive. And basically this will be like a flag or a Boolean that will be yes or no. If the player is alive, then the Boolean will be true. If the player has destroyed the player, then the Boolean will be false. And what we want to do is we can assign that value right now is alive equals true. We'll hit Control S to save. We look at our player, and you'll notice something different about is alive now. Instead of it having a numeric value right here, we have a checkbox. Yes or no. Alright? So if I leave this unchecked, that means false. If I hit play, a check mark means true. Because remember, in the void start function, is alive equals true. So there we go. So anytime that player is destroyed, we can say that is alive will equal false. We can even say is alive equals true when we're declaring our variable. So you'll notice that we hit Control S and save. If we have is alive equals true and it's checked, as soon as we press play, is alive will be unchecked because we set it to false right here. Alright, let's keep going. Let's learn about one more type of variable, and this is the string. A string is another name for a word, a text. Straight up letters and characters making a sentence. So an example of a string would be the hello world, which we just did. Let's say that we want to, instead of typing hello world right here, let's say we want to print out a variable. So first we have to make a public float, and let's call this hello world. And why don't we just declare it right here, and then we'll assign its value, hello world equals, and remember, since this is a string, we have those quotation marks, and we'll terminate there. Then we can go to debug.log down here, and we can just say, instead of typing out quotation hello world, we can just type out the variable hello world. We'll hit Control S to save, and let's see if we print out hello world. Let me spell that correctly. Alright. Cannot implicitly convert type string to float. So what's going on there? Well, if I look back at my code, string to float, what line is that on? 18 and 17. So anytime I call my hello world, alright, and I'm giving it that quotation, I see what the issue is. This is a classic syntax error. Even though the the console window right here is saying look at lines 18, that looks correct. Like, I want to name this hello world string variable hello world. So that shouldn't be the problem. That syntax is correct. The problem arises because when I was declaring hello world, I made it a float. I should have made it a string. Now hello world is recognized as a string variable, which means whenever I assign it quotation marks in the sentence right here, it won't mess up. Before, whenever it was a float, Unity was expecting a decimal number right here. Instead, it was getting quotation marks in a sentence. So Unity was having trouble with that. It couldn't get over it, basically. So with that fixed, with float changed to string right here, and I save, now we get no errors. And remember, now our debug.log is printing the variable hello world. If I hit play, I get the same results right here. In fact, these two lines of code are going to do the exact same thing. We'll just clear this right here. And what I should see is hello world printed twice. Hello world, hello world. So that's two different ways we can use the debug.log function to print out either a straight up sentence or message to our console, or if I wanted to print out a variable right there. So I've kind of gone over the difference between declaration and assignment, but let's look at that a little bit more in depth. Whenever you declare a variable, you define its type and its identifier. So what's a type? Well, a type is what type of variable it is, which in this case is an integer. And the identifier is basically the name of the variable. So we have type int identified as var name. So let's look at naming conventions for our variable again. And I can show you how they correspond in the Unity engine. So you'll notice how in our inspector we have this really nice capitalized nice spaces. If we look in our monodevelop, right, let's get them side by side. You'll see that when I declared type int of player health, I did lowercase p, capital H, or capital H. Well, Unity will read that naming convention and it'll capitalize the first word and then put a space between the second word, and this is what you get. All right. So what happens if we just type that word for word when we were declaring it? This is what I want my variable name to look like. You would think that this would be the way you would declare it. I want both words to have capitalized letters, and I want there to be a space. Well, we'll hit Control S. Syntax error again. Health and class. It doesn't know what's going on. Unexpected symbols. That's because we did not use the proper naming convention here. So let's go ahead and change it back. So proper naming conventions of your variables is very important. Lowercase, uppercase, and no spaces. Don't worry, Unity will translate it to what you see here in our inspector. We talked about assignment. Basically, it's giving a variable a value. And we see that the equal sign right there. Variables must be declared first, though. So let's make an error in our monodevelop where we declare the value, or we assign a value to a variable without declaring it first. Let's see what that looks like. All right, so I'm going to go ahead and make a player ammo count integer. So let's just do ammo count. Remember, I'm using great naming conventions, lowercase, uppercase, and that's going to equal, I want the player to start out with 10 bullets. All right, great. Well, ammo count's in red. Red's usually not a good color. Let's just save it and see what happens. All compiler errors need to be fixed. And let's see what kind of syntax error we're getting within our console window. The name ammo count does not exist in the current context. Basically, Unity doesn't know what the heck ammo count is. It doesn't know what type it is. It doesn't know. All it knows is this random vague identifier. That's because we didn't declare it first. Public int ammo count. And just by adding this one line of code, Unity now knows that ammo count is a variable and it's the type of int for integers. I'll hit Control S, and now all our problems are gone away, and now we have a new ammo count variable within our inspector. And all is right with the world. And when I hit play, since I've assigned the value of 10 to ammo count within void start here, all of my stats should update over here. I have 100 health, 99.9 shields. Currently, is alive is the false, so my player is not alive. You'll see that hello world, it now has a value of hello world within this string area right here. And my ammo count equals 10. So that's variables in a nutshell on how we declare them and how we assign values to them. Now let's look at the difference real quickly between public variables and private variables. Okay? There's two different types. Alright. Let's save this for a second. Let's bring up monodevelop. So what if I had a variable type is alive, and I just wanted it to be, I don't want any other classes or any other scripts in the whole game. I don't want it to be able to look at is alive. So I'll just write private bool, and you'll notice that it's in that same teal color. And something funny happens whenever we make a variable private. So let's keep an eye on is alive right quick. And let me hit Control S in MonoDevelop, and we'll go to Unity. You'll see that is alive has gone away. And now we have a warning saying private field player is alive is assigned but never used. That's basically Unity saying, okay, you've made a variable private. That means you only want to use it within this script, but you haven't used it yet. So basically you've made a variable that isn't being used. Are you sure you want to do that? Okay. So what are public variables good for besides being able to see them inside of our inspector? Well, let's say that we had a enemy script, and our enemy script had lasers that did 10 damage. Well, if a player is hit by an enemy's laser, that enemy laser value, I need to know what that is. And since it's enemy lasers nowhere written within this class, within this script, then I don't know the value of that enemy laser. But if enemy laser, just make an example. Well, I made a JavaScript on accident. We don't want to use JavaScript. Enemy statistics. And now we have two different tabs. Player statistics, enemy statistics. I'll clean this up real quickly. I'm going to declare a public int type called enemy laser. And I'm going to assign it a value of 10. Alright. We're not really going to show this in action, but I figured I was doing too much talking. Should show some visual stuff. So now we see we have two scripts, and these two scripts are going to be able to talk to each other. Because remember, our enemy laser does 10 damage, and our player health is 100. So public variables allow the different scripts, the different classes you see here, to talk to each other. If enemy laser was private, then there's no way player statistics would ever know the value of this enemy laser. So if you want your variables to be able to talk to each other between different scripts, they need to be public variables. So now that we've really gone over the topic of variables, let's see how we can start manipulating the data within variables. And we do that with public and private right there. We do that with mathematical operators right here. Okay? So basic stuff, you've seen these before. There's addition, there's subtraction, there's multiplication, division, modulus, which gives you the remainder. There's the not, which is used with booleans. And let's go back to addition. Let's see how we can use these in action real quickly. Okay? So let's modify our code real quickly. Okay? So instead of assigning values to my player stats and my void start, let's go ahead and assign the values when I declare them. Alright. 99.9f is alive is true. Hello world equals hello world. And ammo count will equal 10. And just because I'm OCD like that, I like to keep all my ints together. So I went ahead and copy and pasted ammo count right underneath there. Alright, now we can get rid of all this assignment stuff because we've already assigned it right here. Alright, and now we have void start set up, and it's kind of looking really clean. We can actually get rid of some of this other stuff right here. Now we have some workspace set up where we can show where addition takes place here. Alright, so let's say that a player gets a health pickup. And let's say the player starts out with 90 health. Alright, if we want a player to gain 10 health, we can simply say player health equals player health again plus 10. So basically what this means is we're saying, okay, player health is going to equal a new value, and we can't just say 10, because if we just say 10, then that means player health no longer equals 90, it equals 10. But we want it to equal 100 because they just picked up a power up. That's why we do the original value of player health plus 10 more. If we hit Control S, player health now equals 10. Well, what's going on here? Well, I declared all this new stuff right here and assigned the values, but it's not updating. Let's reset. Oh, okay, there we go. I just had to update or reset the values on that script. Now when I press play, our player health is increased to 10 because player health equals player health plus 10. Now there's another way we can do this without having to type out so much stuff. Let's pause our game. If we simply just do plus equals 10, as we can see right here, plus equals, it takes the value on the right, adds to the left, stores in the left. So here we go. I'll hit play again. Same thing. So with the plus equals, that gets around the habit of having to type out player health plus 10. Alright. So we can do this in two ways. I'll show it both in action. So we see both ways in which we can use addition right here. I'll pause the game. And I want you to predict what the value of player health will be when I hit play right here. So we do player health plus equals 10. Then we do player health equals player health plus 10. What do you think the value of player health will be? I want to go ahead and press play and we can find out. 110. That's because we've already added 10 to player health. And then we do add 10 again, just written a different way. Alright? So let's just go ahead and delete the long drawn out way of doing it. And let's get in the habit of using the plus equal sign. As a programmer, you're going to want to start learning that the more times you have to press keys on your keyboard, the more time it'll take you to code. So using shorthand whenever you can is preferred, you know, in the programming world. So from now on, I'm going to use the plus equal sign. Alright, now we have subtraction, which is, you know, the subtraction key right here. So let's say that the player ammo count, the player shoots his gun, and we'll go ammo count negative equals, or subtraction equals 1, meaning the player just shot a bullet. We'll hit Control S. We'll pause and keep your eye on the ammo count. The player gains 10 health and loses 1 ammo round. All because of this line of code right here. Alright. So now we have multiplication and division. You'll notice the signs for multiplication is the asterisk on your keyboard, which is Shift 8. And we can see this by saying, let's say, why don't we make a new variable called, or there we go, we got shields. I want to make a new variable called public int player score equals 0, 0, 0. Or let's start out with 100 points or 1,000 points. Control S. So let's say player score, we just hit a score multiplier of 3. So we can do player score asterisk equals 3. And now our player score should bump up to 3,000. We'll just go to, there we go, updated player score. Boom, updated player score of 3,000. And division, let's say the player, after he hits the multiplier, / equals for division, and we'll have his score by 2 for killing a friendly unit. So the player score will be at 3,000. Well, in order to make it not so complicated, let's do player shield. So we're going to have our shield by 2. Shields. There we go. I defined it as player shields. Had to update the variable name to be exactly player shields. And we're going to divide player shields by 2. So what we're going to see is plus 10 health, minus 1 bullet, multiplier of 3 added to our score, and our shields are going to be halved as we press play. And there we go. Some quick different kind of math equations that we use when manipulating values within inside of Unity. Now let's go back to our notes. I'm going to skip over modulus right now, but basically if we look at our example right here, if we did 10 modulus 3, mean 10 divided by 3, the answer is not going to be 3 point whatever. The actual value is going to be 1 because there's a remainder of 1 left over. So 3 times 3 is 9, and then we have a remainder left over of 1. But let's skip over to the not symbol, which is denoted by the exclamation mark. And basically this just flips a Boolean value. And let's see that in action real quick. Alright, so if we have is alive, our Boolean value right here, and let's set this Boolean back up to public, and it equals true right here. Well, let's say whenever the game starts, I want is alive to become switched. And I could just say equals false. That's one way to do it, right? But what if I just want to flip it without having to write false? Well, if we use our exclamation mark, whatever value is alive is set to will be instantly flipped. So we'll hit play here. Let's make sure we save. Notice how is alive is checked because we define it as true. We assign it as true right here. I hit play, and now is alive is flipped. It's now false, and all the rest of our values are updated accordingly. So now that we've gone through our slides, let's talk about the assignment for this chapter. Alright, so it's going to be a two-parter. In the first part, we're going to create a script that tells me about yourself. Okay, we're going to I already have the assignment completed right here. What you're going to do is you're going to create an empty game object called bio for biography, and you're going to create an empty script called biography. All right. And within this script, biography, you're going to create lines of code that do the following things right here. You're going to use 3 or 4 debug.log lines that tell me a little bit about yourself. So just some quick facts, maybe your name, what you like doing, kind of your favorite music. And then you're going to, after you do those 3 or 4 lines, we're going to declare some variables. You're going to make an int for how many years you've been playing games. You're going to declare a float for how many years you've been making games. You're going to make another variable for bool saying if you've ever programmed. So I've programmed before, so my bool would be true. And you're going to make a string for your favorite game's name. You're then in the void start function, you're going to assign values to these 4 variables that correspond to your own personal experience. So you're going to assign a value for how many years you've been playing games. Mine's like 25, so I would assign that variable. Let's go over here. And then what you're going to do with those variables, we're going to use the debug.log line to tell you this information. And it must be grammatically correct and in complete sentences. So you're going to use the debug.log command to use these variables to print out that information. So if I go to my bio, I'm just going to show you an example of what you should see when you press play. You'll notice that my biography script is updated. I have 25 years making games, or playing games. I have 10.5 years, since it's a float, making games. Have I ever programmed before? Yes, I have. What's my favorite game? The Legend of Zelda: Ocarina of Time. And if we look in my console window, we see 1, 2, 3, 4, 5, 6, 7, 8 different lines for all the information I just listed. So I start out with just a random 3 debug.log lines saying my name's Patrick. I'm the instructor of the course. I've been teaching for about 3 years, and I've been working in game development for 5 years. I got my first Nintendo on my 5th birthday in 1989, and I've been playing ever since. And here's where it kind of gets complicated. I use 25 years. I use the variable right here. I have been playing video games for 25 years, so I actually used my years playing games variable in this debug.log line. I do the same for all of these values for the rest of the debug.log lines right here. 10.5 years. It's true. I print out the true for the ever programmed before. And then I print out the string variable, Legend of Zelda, Ocarina of Time, right here. So I hope that's not too confusing. If you have any questions, just let me know. And the second part for this assignment is we're just going to set up a player stat script. You saw me do it a few minutes ago, doing all the examples of all the variables and stuff. We're just going to create a simple public variable with health, ammo, score, alive, and a player name. We're not going to mess with any of these values real quick. We'll get into that next chapter. But I just want you to go ahead and get in the habit of setting up a player stat script and assigning it to an empty player game object. Alright, so again, here are all of the stats and parameters for the assignment. Hopefully it's pretty clear. We're just going to be using debug.log and a few variables. Just let me know a little bit about you guys. Alright, if you have any questions, you can post it on the video. You can email me personally, or you can post it within your learning modules. Alright, thanks guys.